Okay, now we are going to start with the we are going to check the energy conservation in case of pendulum. So a pendulum is actually a string with a bob like this. Okay. Okay, now as long as this is like, let's assume that this is the mean position of the pendulum. Mean position means this is the position where pendulum actually rests. So as long as pendulum is in this rest state, its speed is 0. Speed 0 means its kinetic energy is also 0, because in rest state there is no motion. When there is no motion, there is no kinetic energy. Okay, when this pendulum okay, now you can see the height of this pendulum, like the ball is like, just match the height of this ball with this surface is 0. There is no height of this ball from the surface. That's why its potential energy is also 0. When height is 0, potential energy is also 0. Okay, let's assume that we moved this pendulum. Oh, it's not supporting. Okay, let's assume I moved this pendulum from here to here. Now pendulum is here. Let's assume that this position is, this point is point A, or this, the name of this position is A. Okay, now let's see. You can see that right now, initially when it was at mean position, its height was 0. Now it is at position A, where its height is not 0, it has some height. It has some height, and due to this height, it will have some gravitational potential energy at position A. And the source of gravitational potential energy is the work which we did to move pendulum from mean position to position A. So the source of potential energy is the work done on pendulum to move it from mean position to position A. This is the height h, which is actually which actually gives the potential energy to this object. When pendulum is released from position A, it will slightly move in downward direction. Let's assume a new position here. Here. At this point, the height of the pendulum is comparatively decreased. Like, the height of the pendulum is decreased, so it will have less height as compared to the previous height. So its potential energy gravitational potential energy will decrease at position A. So suppose this new position is position C. At position A, it its height was large, so its gravitational potential energy was large. At position C, its height is comparatively decreased, so its potential energy is also decreased. Now we know that as per law of conservation of energy, energy can neither be created nor destroyed, and we can see some of its potential energy is decreased. So now that decreased amount of energy is converted into kinetic energy of this pendulum, and pendulum would be in state of motion. So pendulum is in state of motion as well as it has some energy. So at point C, it will have both forms of energy, kinetic energy as well as potential energy. When the pendulum starts continues its motion, it will reach to mean position here, and the pendulum is also with this machine. And at this point, the pendulum have zero height because it is near to surface, so its height is zero. It means its gravitational potential energy is also zero. But it is in state of motion, so at this point there is only one kinetic energy with ball, and potential energy is zero because its height is zero. Okay, now pendulum will not stop here and continues its motion towards the B side. So suppose we have a B side here. Now the pendulum will never stop at mean position but will continue its state in opposite direction. This is because the pendulum is unbiased. Oh, sorry. What I mean to say is, when like at mean position, like the pendulum is coming like this and will go like this, because this is because of inertia. So pendulum continues its state of motion because of inertia, and we are assuming that no air friction, nothing is present here. Okay, when pendulum would be at this position, it will have zero kinetic energy, but when it will move from one point to another point, its kinetic energy starts decreasing, and some of its portion is getting converted into, some of its height is starts increasing, and some of its kinetic energy is converted into converted some of its height. Due to its height, some of its kinetic energy is converted into gravitational potential energy. So now the pendulum continues, keep on moving in upward direction, like here. The pendulum will go like this, and now you can see the pendulum has certain height, and at certain height it means it has potential energy, and at this point, just for a small interval of time, the pendulum will take rest and will start moving backward in direction. So at this point, the pendulum has some height, it has potential energy, it's in rest state, so it has no kinetic energy. So here, when we were at point A, the pendulum has only potential energy. Similarly, at point B, when the pendulum will take a pause for an interval here, its speed would become 0, its velocity would become 0, its kinetic energy would also be 0. So we have only one option of potential energy, like A and like B. If there is no air friction or any other material, if there is no friction or air, then there would be no friction, no air resistance. Then we can say that the kinetic energy and potential energy like oscillates. Sometimes we have kinetic energy, then potential then kinetic potential kinetic potential kinetic. Such type of scenario is repeated again and again. So when pendulum moves from mean position towards extreme position, its height increases. It means its kinetic energy it means its potential energy increases, and there is okay, at mean position the kinetic energy of the object of the pendulum is maximum, which decreases with the passage of time. Here some of its kinetic energy is converted into potential energy. Here the kinetic energy is converted into potential. Here like at this point comparatively twice or thrice. Like you can see, whatever the amount of potential energy was 0, now maybe 1 time, maybe 2 times, 3 times, like the potential energy is increased, whereas the kinetic energy is decreased by the same amount. Similarly, when the pendulum will reach at this extreme position, it will take a short rest. When it would be in state of rest, there would be no kinetic energy. So that's why at extreme position, whether it is here or here, its kinetic energy is 0 because of rest position. Whereas potential energy is concerned at B and A, the potential energy, gravitational potential energy would be maximum.
Hello, sir.